In part 1 of my conversation with Professor Debarati Chatterjee, we covered her journey to becoming an astrophysicist and working at IUCAA. Then we talked about key concepts needed to understand gravitational waves and modeling pasta-like structures within neutron stars. In this part, we'll focus on challenges of building LIGO-India Observatory and the importance of public outreach. I hope you enjoy this one. We've been talking about LIGO. Why don't we get a little bit more into it, which is the Laser Interferometer Gravitational Wave Observatory. And it's a complex piece of machinery. And even from like my cursory understanding, it's a complex enough project. It's not just in terms of scale, its size, but also the instrumentation, the engineering, and all that is going into it. So but how would you explain it in a little more simpler terms than that?
So this is basically, you mean how the interferometer works? Is that?
Yeah. Some just briefly about, before we get into complexities, how would you explain the high level concepts there?
Okay, so the idea is, so this gravitational waves that Albert Einstein predicted 100 years back. So the question is, why did it take us 100 years to detect them, right?
Mm-hmm.
Knew they were there. So the first indirect detection actually came from an observation of pulsars by Hulse and Taylor. So what they did was they, followed the trajectory of two neutron stars as they were falling into each other and merging. And they saw the signal of these pulsars and said that, yeah, they were exactly following the prediction of Albert Einstein by, following the rules of general relativity. So we knew that they existed, but it took us 100 years because they are extremely small. They are minute.
Mm-hmm.
These perturbations in space-time, even if it passes through us, we will not be able to detect them.
Right.
It's like its amplitude. So if you have like a scale, its amplitude is something like 10 to the minus 22, 23, which is like 1 divided by 23 zeros. So it's almost like detecting a hair on the surface of the moon. And this is why LIGO is today one of the most precise instruments in the world. And, to make this work, it required generations of technology development.
Right.
Has really, exponentially improved in the past decade, let's say, and made this possible. So the idea is that, very simply speaking, an interferometer is something that is used even in optical experiments. So it's kind of like, and the most simple configuration is an L-shaped detector, which means there are like two arms perpendicular to each other. There is a beam of light, a laser light, that is made to go through these two arms. There are mirrors at the end, which are these light rays are reflected back towards the center, and they, interfere to produce a fringe. And
Right.
if any wave passes through it, then it's going to, move one of these arms, and therefore it, there is a difference, a change in the interference pattern, and we can say a wave passed through. So this is like the textbook story of it,
Yeah.
but what goes in there is extremely, extremely complex. Because imagine what you do on a tabletop experiment. This is something when you try to reproduce this to actually detect gravitational waves. These LIGO detectors, for example, are 4 kilometers. Each arm is 4 kilometers long. So you have the curvature of the Earth. You have to place a tunnel which is going 4 kilometers, and you have to correct for a lot of things. Then you need a laser light that does not disperse that distance. You
Right.
need to suspend the whole thing inside a vacuum and in ultra cool temperatures in order to isolate it from any kind of thermal noise, or even if you walk around, even if there are cars, so you can produce noises. So it is an extreme technological feat to try and isolate these tiny vibrations from any kind of human vibrations or any other vibrations. So so I'm not an expert of all these fields. It's impossible. So it's like an enormous teamwork, which involves, 100 institutions over 18 countries or so, and thousands of scientists, each of whom, there are researchers and engineers and students. So it has taken many theses and many projects in order to, come up with innovative ways of how to do this in the most efficient way. So it's an enormous technological feat. But yeah, I think, this is the simplified picture of what I
Yeah.
can say, how it works.
Yeah, yeah, absolutely. And reading through Jenna Levin's book about black holes and the black hole blues, and she talks about how multiple careers have gone into making this into a reality, and it almost didn't happen as well. So this is it's almost like a thriller that is happening in real time in the scientific world. So hats off to people who have gone through it and made it happen, and all of you are making it happen again. I'm curious to know if there is any difference in the India side for LIGO than that compared to other detectors.
Yeah, so actually different detectors contribute differently to the development of gravitational wave science. So in the beginning, for example, there was the smaller detector called GEO. It's a 500-meter detector that was in Germany that is still operating, but it is now used mostly to, test different technologies that can be developed. Virgo is a detector in Europe near the Italian and French border. So this is, I think, 3 kilometers in length of each of the arms. And the LIGO detectors are 4 kilometers long. So will the Indian LIGO detector be. So the Indian LIGO detector is more or less a copy of the LIGO detectors in the US. So there are two of them in Hanford and Livingston. So the Indian detector is going to be like a copy of that. There is also the Kagra detector right now, which is operational very recent, since recent times in Japan. And what is going on is through several, generations, the detectors are getting more and more sensitive. So with technological advancement, so the first observing run was called O1, and then the second observing run, third observing run is basically when we start, now to talk about more and more sources, and we detect more and more sources, and understand gravitational wave science better. Right now, we are at the fourth observing run. So India, when the detector will be completed, the configuration will be more or less based on what is there in the LIGO detectors in the US. As you know, as we are progressing with each observing run, so at the point when LIGO India comes into the picture, it basically has to catch up with that level of sensitivity, which will be there in future. I don't know, it seems very difficult to predict right now because, so many advancements are happening. But what is good about it is that the entire gravitational wave community is extremely, supportive and collaborative. So these technologies are shared so that we can all advance in gravitational wave science. And so I'm assuming that the one that will come up in India will be at the forefront of research so that it is at par with the, the observing run where it is going to, step into the picture. But also, in any case, the position of the LIGO detector in the global array of detectors is going to help the entire gravitational wave community anyway, because this is something called triangulation, like why we need 2 years to understand where some sound is coming from. So we need like that, more detectors, scattered at different longitudes and latitudes so that we can, pinpoint where the source of gravitational waves are. And therefore, the position of LIGO India in India is going to help with this enormously.
Yeah, yeah, that makes a lot of sense. And you mentioned about the observation runs. And I'm assuming that the detectors have to be in sync and locked to actually observe an event happening at the same time. And I'm sure that there are challenges there itself, sort of coordination between multiple sites. Um, so I'm just curious to know about the international collaboration that you talked about. Is and Just curious in terms of funding, is it funded through the central government? Is there funding generally available? How does the India site work?
Yeah, so LIGO India is actually, based on an MOU between the government of India and NSF in the US.
Mm,
So basically from the Indian side, the development of the detector will be supported by the Department of Atomic Energy and the Department of Science and Technology. While from the US side, we will also be able to use, the detector configurations that are already existing in the US. But again, like I said, that, as we advance, we will probably also need, better technology. So this is something that is collaboratively being developed. So there are four main institutions in India, in LIGO India, that are involved in this. So basically, it's DCSEM in Mumbai that is, in charge of construction of, the site development. And RRCAT in Indore, so the Raja Ramanna Center for Advanced Technology, and IPR in Gandhinagar. So it's the Institute for Plasma Research. So these are developing, the optics and lasers and all these technologies that will be required. IUCAA is involved in currently in research and recruitment and other things, and so it will also step in once the science run begins, so that we
mhm.
can yeah, like infer the physics from the gravitational wave science from these detections. So right now, so it is, in this construction stage, but yeah, I mean, like I said, it is shared information and shared expertise among many different institutions.
Yeah, no, that's awesome to know. And that's one of the reasons I guess that you're visiting US and I'm sure bring the channel of information between different organizations. So that's also great. Um, cool. I could keep talking about it, but I was thinking let's switch gears and go a little bit into public outreach. You're the chair of public outreach for LIGO India. So I just wanted to know your thoughts on why is public outreach important, like in your view?
Yes, I personally, I mean, I have been involved in outreach since a long time. I was also ambassador for science in France before joining the LIGO project, and I was also an ambassador for science for Euraccess and several, also ambassador for women in science and so on. So I think outreach is extremely important for several reasons. So first of all, uh, you know, fundamental physics or fundamental science, is something that is not very easy for common people to understand. Although people I have seen in general have a lot of respect as to, what is going on in the field of research, but it is, I think, a responsibility of the researchers themselves to also to try and communicate, what is going on in their field. And I mean, not only the excitement, because I feel it is important to, transfer the excitement to young students so that they can know about these fields, and there are more students who are, coming into these fields, but also for people who are working in other fields to know exactly what is going on. And this is one of the reasons we are doing research, right? So to advance the human knowledge to
Right.
about the world around. And I think this is very important. I mean, I could be excited on my desk about a discovery I just made, but until I share it with people, I don't think, it's worth it. So yeah, I'm very excited about outreach in general, but I think for the LIGO India project, it's even more important because so first of all, because LIGO India is a mega science project which requires involvement, from all these young Indian students who are going to be the people in the future who are actually going to use this facility. So even now, although we are now involved in building it, we require a community in India who is aware of what is going on, why this is important, and where India stands, because also it will require, cutting edge technologies in so many different fields, not only in, science and engineering, but also in computation, data science, handling the amount of data that it will produce. And also because it is going to be one of the most precise technologies that is being developed in India, and, how important it is to the whole world. So I think, everybody in India needs to know So there are different, sides to outreach for the LIGO-India project. So first of all, there is this responsibility of communicating with the international, where LIGO-India project stands in the global area of gravitational wave observatories, and to participate in this international effort. So that is one of the, aspects. The second is that there are also many institutions in India. There are about 15 institutions in India who are doing gravitational wave research already in collaboration with all these existing detectors. And so there are different, universities, IITs, and research institutes. So we also do, outreach for the discoveries that they make and their involvement.
Mm.
The students and people come to know about these efforts. And thirdly, because now this project is coming up in, a rural part of Maharashtra called Hingoli. So even there, building a detector of this scale, first of all, the local people need to know why and what we are building there and why we are building there, so that there is, no lack of information. So from their side, some of them have, a misunderstanding. Is this a NASA project? Is this a nuclear project? What is going on?
Right.
So we need to, first of all, inform them about what is going on. It's not really so easy to, just tell a villager about what a black hole is or gravitational waves. It's a very difficult concept to communicate, but we try our
Right.
best, transfer this excitement to them, because they are the ones who should be most proud that, LIGO-India, is the name of this detector, comes from this region, Aunda, the village where this is going to be built. And I think the people deserve to know that, that they are important on the world map and why it is so. So yeah, not only that, I think it's also important for, science policymakers and stakeholders to know about this, so that we do not have a lack of support and lack of funding in order to advance the project. So I think, yeah, I mean, outreach has a lot of different responsibilities. Popularization of gravitational wave science in general, but also, communicating the importance of this project, and, building a community around gravitational wave science in India, so that this project can be, taken to the place where we want it to go in future in India.
Right. Right. That makes a lot of sense. And it's a frontier of scientific discovery. So it's an exciting time for more people to be involved, and there's more information out there. And I guess in some ways, the tax dollars, tax money, tax is going into it. So it's also good for people to know where their money is going and why is it so important. Because we have a lot of other topics to talk about, but the scientific aspect of it is also exciting. So yeah, really appreciate you getting involved in this, and just I'm just happy to contribute in some small way, hopefully to get this word out a bit more. So that's really great. So before we wrap up, I just wanted to ask if I missed anything, asking that people should know about the project.
I think often, what happens in fundamental physics is we get asked, like, why build this detector? Of course, I think this question comes up a lot in the Indian context, because we have a lot of other issues to deal with. And yeah, and I would say that in this aspect, LIGO-India project is a great opportunity for Indian students, Indian researchers, as well as, scientists, engineers, and everyone, because this is why it's called a mega science project. It almost touches everybody's lives. It's, the development of indigenous technology, which is in so many fields, from lasers to optics to suspensions, mechanics, data science. So this is going to push India to the forefront of research in not only research, but also technologies. So developing what is required for this project is already going to boost, many different fields of innovation in India, that I think is going to benefit many other fields, be it medicine and be it agriculture. I'm sure there will be offshoots from this project. And so this project itself coming up in a place like Hingoli is going to boost the, the local economy and the involvement of, be it transport or be it constructions, linking, Hingoli on the map of India. I'm sure it's going to be one important place in future. And also it's giving, all these students and researchers across different institutions in India, even the remotest corner of India, to be involved in such a grand project of this scale, which is so important. And already gravitational wave science is something, I think, which has touched every single, research field, even, indirectly, directly or indirectly. So I think, yeah, this is, I would say this is a path-breaking opportunity for India to participate in. And yeah, it would be important for us to communicate this information to the next generation, so that the students and even the people of India can be proud of this project, and support it to gain the achievements that we dream of, that this project should be able to achieve.
Yeah, absolutely. And as you're pointing out, there's no limit to where what applications can come out of this, and this is a mega project. So that's fantastic. And the way you're putting it is also very sensible. So I don't have a better way of saying it. So thank you for thank you for your time. Thank you for delving and getting deeper into these topics, Professor. And I look forward to talking to you once more in the future. So thank you again.
Thank you very much for having us. Thank you.
All right. Take care.